This is Srija from Janssen Institute of Technology. We have done a project on OTP-based wireless charging for EV vehicles using geo-tracking system, along with my team members Raviteja, Niklesh, and Raghuvendra Reddy. We have chosen this topic because in this emerging technology, we are using electric vehicles a lot. The limitation of electric vehicles is its charging, which traditional systems we have charging stations where we have to wait a lot of time for charging our vehicle. When it comes to national highways or long distance, we may not find charging stations wherever we require. So we came a solution, wireless charging system. Here in our solution, we'll be having a transmitter device, receiver device, and a transmitter web application and a receiver web application. Our system starts with a receiver device where voltage sensor checks the battery status and gives notification to the user. When the voltage is low, status of the battery is low, he can request for the charging using request for charging button from the web application. Then notification will be popped up in the transmitter's web application such that the transmitter person can check the notification and track the geolocation and give a OTP. When the OTP is verified from the receiver sides, the wireless charging gets completed. We have taken a prototype. Here we have used a 6-volt battery. This gives the charging and power supply to the components. This is a transmitter device. We are having a 6-volt battery here, node MCU, microcontroller, buck converter, relay module, LCD display, and a transmitter coil. But 6-volt battery gives charging to the receiver device. How it works is this is a 6-volt battery, and the receiver coil transmitter coil only converts 5-volt voltage. So this buck converter transfers 6 voltage to 5 voltage, and this is a relay module. When OTP is verified, it gets activated and acts as a switch button. Then the charging will be transferred to the receiver. These functions of node MCU are sending the EV locations via Wi-Fi, receiving charging requests from the app, monitoring the battery's voltage and charge level, starting and stopping the charging process, controlling and coordinating the components. Display is used to show the status of the battery, receiving charging and the transmitting charging. Here comes the receiving device. Here again we have a 6-volt battery, LCD display, GPS module, node MCU, voltage sensor, rectifier, bridge rectifier, and power distribution center. Power distribution center is used to give current to all the devices on the board, and battery is used to receive the charging. LCD display is used to show the status of the battery and charging received. GPS module tracks the location and sends it to the transmitter device. Node MCU functions are as same as the transmitter devices. Rectifier from transmitting coil will be receiving it as a AC current, but our battery needs a DC current. So this rectifier converts AC to DC. This is a bridge rectifier which converts full rectification. And the voltage sensor checks the battery status and shows the status of the battery to the LCD display. This is a transmitter's web application. We have used a basic level HTML to design this web application. We can see date, status of the battery, and generate OTP, charge now. This is a receiver's web application where we can get the OTP what we have sent in the transmitters and enter this OTP here and charge now button, and we can request for the charging when the charging is low. Initially we can see the status of the battery and charging stopped in this LCD display. Here in this display we can see wireless EV charging off. This is a receiver's web application. When the charging is low, we can request for charging using this request for charging button. When we click that button, when we request for charging in receiver web application, we can see a notification in transmitter web application. When we allow, we can get the vehicle's live location as latitude and longitude. Here we can generate a OTP. Here I am generating the OTP 5678 and charge now. I have got that 5678 OTP. When I enter this OTP again, send charge now, activated, gets activated as the OTP entered is the correct. Now we can charge the We can charge using these wireless coils. In this display, we can see that electric vehicle charging started. This indicates that transmitter device is when the charging is transferred, we can see that status of the battery here. This transmitter coil and receiver coil, we can maintain the maximum distance of 5 centimeters. As we used a small coils here, the distance is small here. When it comes to the live electric vehicles, we can use large size of coil. The time required for charging depends on the size of the coil, and the distance between two vehicles depends on the size of the coil. This is a basic level prototype which we have designed based on wireless charging idea. We can implement this idea in larger sectors by other emerging technologies and implement this in future to implement it directly for electric vehicles to wireless charging.